Hi guys, welcome to this lesson on NEET 2017. So we are here to discuss the physics question that appeared in NEET 2017 paper. Now we'll today discuss from question 16 to question 20. Earlier in the three lessons we have discussed from question 1 to 15. I am Vikas Joshi. So now let us begin our journey. Okay, so the first question for the day. The given electrical network is equivalent to, this network is given, some gates are applied, and A and B are the input, Y is the output. So it is asking what will the output Y equivalent to which gate? OR gate, NOR gate, NOT gate, AND gate. Upon analysis of this given electrical network, we'll find that this is a OR gate, this is a NOT, so it will become NOR. Okay, now this NOR gate, in the next part, this NOR gate has been self input, has the self input. So upon self input, the NOR gate becomes NOT. So up to this part, this NOR and NOT, say NOT is also there, NOT is also there, so both nullify. So all we have left up to here is equivalent to OR. Now OR is applied as NOT, is input to NOT gate. This is NOT gate, so it will become equivalent to NOR gate. Simple. So this output will become equal to NOR gate. So our option is second. Okay, now second question is the de Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T Kelvin and mass m is, four options are given. Now first thing first, okay, don't like panic with this words like thermal equilibrium, heavy water, something like that. Okay, if you are clear with your concepts and you remember your formula, the formulas for kinetic energy, you will be easily able to solve. We have two formulas for kinetic energy, I hope you remember, and one is from linear momentum and another is from modern physics. Equate both and you will get the answer. Okay, so now let us look at the solution. The solution is, say we are having one formula for kinetic energy, 3 by 2 kT, where k is the Boltzmann constant. Okay, yet another formula we are having with a linear momentum, that is kinetic energy is equal to half p square m. Now equating these two parts, we'll get a value for p, that is under root 3 kt 3 k mt. Okay, now we all know that h is equal to h by p. H is the Planck's constant. Okay, so now we are having h. Now we already derived p, so putting the value of p, we'll have the value of the wavelength. This is de Broglie wavelength. We'll have the value h upon under root 3 k m t, and that option matches with the first one. Okay, so first is the correct option. Now let us look at another problem. Okay, so which one of the following represent forward bias? Diode. Okay, so this is diode. It is asking this, these are the four conditions given, so which one is the forward bias? Now students, you need to remember that the necessary condition for the forward bias, what is the necessary condition? The necessary condition is P should be greater than N. This side should be greater than this side, positive should be greater than the negative side. Now if you'll see, if you'll careful, I have written down the options here. If you'll carefully see in all of the option except this, positive side is less than the negative side, but only in this option 0 volt, obviously 0 volt is greater than -2, P is greater than N, only in this option. So this option we are having the forward bias diode. And where is this option? Fourth one. Okay, so our answer should be fourth one. Now let us jump to the next question. Okay, so this one comes from solenoid. Okay, first thing first, we must remember the formulas, all the formulas. Without formulas we won't be able to do this question. Don't even dare to touch this question if you're not aware with the formulas, because it will only and only waste your time. Okay, so what does the question says? Let us look at the question. A long solenoid of diameter 0.1 meter has 2 into 10 to the power 4 turns per meter. At the center of the solenoid, a coil of 100 turns and radius 0.01 meter is placed with its axis coinciding with the solenoid. The current in the solenoid reduces at a constant rate to 0 ampere from 4 ampere in 0.05 second. If the resistance of the coil is 10 pi square ohm, the total charge flowing through the coil during this time is. Okay, so now these are the four options given. Now let us look at the solution. We all know that B is equal to mu naught Ni. Okay, so value we know the value of mu naught 4 pi into 10 to the power minus 7. N is given the number of turns to 4 into 10 to the power 4 meter turns per meter. We have put that value. I we don't know, so upon this we'll calculating, we'll get 8 pi into 10 to the power minus 3 I. This is the value of B. Now we'll find the flux linked with the coil. The flux linked with the coil will has the formula ban. Remember, it's at ban. Okay, B we have already calculated. A that we'll put the value, and N. Okay, so we are having, so what we'll do is we have put the value of this B 8 pi into 10 to the power minus 3 I have written here. Okay, the value of A. Now let us see. Okay, is pi r square area, and r is given to us. Okay, what is r given? 10 to the power minus 2, so square will become 10 to the power minus 4 pi r square. And n, see the question 100 tens, that is also given. So n is equal to 100. Upon solving this, we'll get 8 pi square into 10 to the power minus 5 I. Now the EMF induced in the coil will be the differentiation of flux with respect to time, that is dphi by dt. Okay, so we are having 8 pi square into 10 to the power minus 5. Okay, so now the current has been reduced to 0 from 4. So 4 is the upper and 0 is the lower. So putting the value, we are having 4, and time is given. What is the time given? 0.05 seconds. So 5 into 10 to the power minus 2. Upon solving this, we will get 32 pi square into 10 to the power minus 5 upon 5 into 10 to the power minus 2. Now what is the current? Current is E by R formula. E, we have already reduced the value of E, putting the value of E, and we are having the resistance is given as 10 pi r square. So we have put the value of resistance also. So upon solving this, we'll get 32 into 10 to the power minus 6 upon 5 into 10 to the power minus 2 ampere. Now what we need to find is charge, the total charge flowing through the coil. Now the Q is equal to IT, basic formula. Okay, so I we are having, time we are having 5 into 10 to the power minus 2. This will get cancelled, so we are having 32 into 10 to the power minus 6, that is nothing but 32 microcoulomb. So what is the answer? B. So guys, you have seen that the whole question was based on full formulas, 4 formulas that we have used, 4 to 5 or 5 formulas that we have used. In each stage we need to move from one part to other. We have to link them to get the first thing that should come to our mind is, I will find charge. I need to what is the formula for charge? IT. So I need to find I. Now how I will find I? I need the EMF, resistance is given. Now how I will find EMF? I need the flux to find. Okay, how will I find flux? I need to get the value of B. So in this way, thinking in the backtracking the question, we can solve this question. Okay, next question. From optics, Young's double slit experiment is first performed in air and then in a medium other than air. It is found that the 8th bright fringe in the medium lies where the 5th dark fringe lies in air. The refractive index of the medium is nearly 1.59, 1.69, 7.8, 1.25. Okay, what we need to look at this question is the bright fringes in the medium is appearing where the fifth dark fringe was in the air medium. Okay, so now let us look at the solution. This is the setup of Young's double slit experiment. These two are source S1 S2. Small d is the distance between these two. Let's say that y is the distance where the dot is appearing from the this central fringe, that is O. Okay, now capital D is the distance between the two screens. Okay, now what is the formula for the bright fringe? The formula for bright fringe is y is equal to n lambda capital D by small d. Okay, now what about lambda? Lambda in the medium, since it is put in the medium it becomes lambda of the free space wavelength, that is lambda naught upon mu, that is the refractive index. So lambda in the medium becomes lambda naught by mu. Okay, for the dark fringe we are having y is equal to 2n plus 1 lambda d by capital D by 2t. Okay, this is the formula that you must remember, otherwise you won't be able to solve the problem. So let us consider that the eighth bright fringe. Now one thing you also must remember, that while doing the Young double slit experiment, the central fringe is the bright fringe only. Okay, this one is the bright fringe only. So eighth bright fringe will form we have to count it from the central bright fringe. So total bright fringe will be 9. Okay, now it is given that the bright fringe is equal to dark fringe. Okay, the position are equal. So n lambda d upon capital D upon d is equal to 2n plus 1 lambda capital D by 2t. Okay, now putting the value, now we will put now we'll put lambda as lambda medium, since it is in the medium, and n is equal to 8 because it is the 8th bright fringe. Okay, now for here it is the 5th dark fringe. So forget this is the formula for dark fringe. Okay, so it will form at, we are having total 9 bright fringe. So what value of n should we put to get 9? 4. So we'll put 2 into 4 plus 1. Lambda will remain lambda since it is in air, capital D upon 2d. Now we'll cut whatever we can cancel. We can cancel from both the sides, and from with replacing lambda in the medium by lambda naught by mu. So what will the final equation that will form is 8 into lambda naught capital D upon mu into small d is equal to this 9 lambda naught, that is in air, capital D upon 2t. Cancelling d capital D lambda naught, we'll find that mu is equal to 16 by 9, that will be equal to 1.78. Yet again this was quite I will say question above the moderate level and below the difficult level. It was between moderate to difficult, and it will hardly take 1.5 minutes to solve this question if you are clear with your concepts. Okay, so this was the question, the last question for the day, and thank you for watching this this lesson. You can find me on Unacademy on this link, unacademy.com/user/VikasJoshi official. You can watch all my courses and lessons here, and please do rate, review and share it with your friends, because sharing is caring. We need to share the studies that we are doing so that all are benefited, because padega India tabhi to badega India. Thank you.